So let's suppose I'm going to, first of all, ask you, what is a linear equation? Can anyone give us an example of a linear equation? And how do we know it's linear?
It's a line that has a constant slope.
Correct. It's a line that has a slope, of course, the straight line. Yes, please. Maureen. It has a y and x intercept, Maureen. Thank you. But can anyone give us an example? I would just like to write an example. Please, Maureen. Excellent. Minus 6. That's a perfect example. This is indeed a linear equation. How do we know it's linear? We know it's linear because, first of all, it does have both variables have power 1. Power 1 for the variables. Second reason is there are no variables in the denominator. So 1 over x, for example, is not linear. And also, they're not products of variables. So, for example, xy equals 4 is not linear. Although both x and y have power 1, that is not linear. A product of two variables is not a linear function or a linear equation. Very good, thank you. So now we want to graph this. Oh, this is gone. So we want to graph this using x and y intercepts. Graph this equation that you just came up with using x and y intercepts. In order to graph using x and y intercepts, I have to find them first. So this is a coordinate system, and we have to establish from the very beginning, what is the equation of this line? Well, first of all, what is its name? It's the x-axis. Very good. Indeed, this is the x-axis. Good. So what is the altitude of the x-axis? How high is it or how low is it?
It's at y equals 0.
Excellent. Y equals 0 is the equation of the x-axis because the altitude is 0. Now, since we are here, can you please tell me if I say that this is 5, can you give me the equation of this line? What is the altitude? Please, Bob.
X equals 5.
Careful.
Or y equals 5.
Excellent. So, indeed, any line that is horizontal refers to the altitude and nothing else. How high or how low? Can anyone else give us the equation of this line? And I'm going to say that this is a 2. Of course. Yes, of course. Y equals -2, of course. Thank you. Of course, you waited for me to make the correction before you said what you said. Good. Very good. So what about this line? What is the name of this line? Excellent, of course. It is the y-axis. But now this one does not show altitude. This one shows position. What is the position of this line? Has nothing to do with y, because it's not altitude. It's position. Not yet the slope. We're going to talk about the slope in a minute. What is the equation of this line? Like we know that the equation of this line is y equals 0. What is the equation of this line?
So along that line, all x is 0.
Very good. That's the equation of that vertical line. So position means x. Altitude means y. One more time. Position means x. Altitude means
y.
Exactly, right? All the lines that refer to altitude have y equals. All lines that refer to position have x equals. So for example, I'm going to draw a line And I'm going to say it crosses at -10. Can you please give me the equation of this line? It's not altitude. X equals? Of course. Let's also look at this one. Let's say it's at 9. Can anyone give us the equation of this line? It's not altitude. It's position. We have to differentiate between the two. Very good. Do you see the difference? One more time. This is very important. Do we see the difference? Altitude refers to Y. Position, I'm standing here. Position refers to X. Is that clear? Everyone? Okay, perfect. What does this have to do with what we're talking about? A lot. So finally, I would like to look at 3x minus 6 and find the x-intercept and the y-intercept. If I want to find the x-intercept, I have to make what? For the x-intercept, I make something equal to 0. Very good. Because of this equation, I'm looking for a point here. It has to have y equals 0. Very good. In a minute, we'll go back. For the y-intercept, I make, to determine a point here, I make what? Exactly. So please remember that's our next step. We have to remember this. Every time, that's why I showed you those equations, so you don't have to just simply memorize, okay, I have to memorize now that when I determine the x-intercept, I have to make y equals 0. No, you don't have to, because you know that the equation of the x-axis is altitude 0, which means y equals, Morgan?
0.
Excellent. And then I know when I have to determine the y-intercept, I determine the position. And the position on the y-axis must be equals, excellent. So here's what I do next. I forgot to mention, I do not claim that my method is the best or the only one. If you go to the math lab and they show you a different method that you understand better than mine, you can forget about mine. Use the method you like. I'm fine with that. You will never hurt my feelings. Okay, but I will show you the method that I think is the easiest, but you may find another one that is easier, even better for you, or easier, okay? So for the x-intercept, I have to make y equal to 0. So this is 0. 0 equals 3x minus 6. When I move a term from one side to another, I change its sign. That's the easiest thing to say. I still believe that. So when I move -6 to the other side or add 6 to both sides, I get 6 equals 3x. And then I know that x must be 2. At this point, before I look at the other one, I have to write the ordered pair. Can anyone give us the ordered pair that is the x-intercept? 2, 0. X is always first. Thank you, Joy. X is always first. Y is always second coordinate. Perfect. Okay, so now this is even easier. This time I have to make x equal to 0. Look what I do. How much is y when x is 0? That's it. What is the ordered pair now?
0.
That's it. Perfect. So then I'm ready to graph. I will plot 2, 0, 1, 2. I will plot 0, -6, 1, 2, 3, 4, 5, 6. I will connect and extend the line. I will put 2 arrows up and down. I will write y equals 3x minus 6 next to it, so I know what I graphed. Few questions for you here. Ready? Can anyone give us the equation of this line?
X equals -3.
Excellent. Can anyone give us the equation of this line? Careful, it's altitude. Altitude. Y equals. So this is 0, -1, -2, -3, -4, -5. Clear, everyone? Okay, perfect. Okay. And I would like us to look at a word problem now. You choose. My colleague, who's one of my colleagues, I'm on the calculus committee, I'm not on the algebra committee, so I'm the calculus committee, so they selected some problems. It doesn't matter, we can select any problem you want. What type of equation is this? Right, how do I know? X and Y have power 1. There is no product of X, Y, that will not be linear, and there is no X or Y in the denominator, so I know it's linear. A new car is worth $45,000, is depreciating in value by $5,000 per year. Okay. Describe the car's value in dollars after X years. This function, the mathematical model describes it. Find the x-intercept, and also identify what that means. So how do I find the x-intercept? The x-intercept. Excellent. So let's solve for, replace y with 0 and solve for x. Find the x-intercept. What will I do next? We're going to do this together, but I just want to emphasize what we're trying to do. Find x equals to 0 because I want position now. Okay, perfect. What will that mean? We'll in a minute. Use the intercept to graph the linear equation. Okay, and use the graph to estimate the car's value after 5 years. That's the problem. Is that clear? Okay, let's start. So this is 77 on page 725. I did not talk about these documents just yet. So after we finish this section and the next one, I will talk about these documents. The last 3 documents that I didn't mention anything about yet. Very good. So we copy okay. So we have y equals -5,000 x plus 45,000. And first question, part A, find the x-intercept. Again, you already told me. X-intercept means altitude 0, which means y equals 0. So 0 equals -5,000 x plus 45,000. This is the term that I will move to the other side or add if you'd like. You don't have to use my method, but if you get used to it, it's going to cut a lot of, it's going to be a shortcut, in other words. It will really be a shortcut. So 5,000 x equals 45,000, and I have to find x. How much is x? How do I determine x? Yes. First of all, cross out the 3 zeros from each side, because that makes it easier to divide. And 45 divided by 5 is 9. But what is the measurement? It's okay. Now, what is the measurement unit? So, yes, if I tell you I have in my pocket 10, you're not going to think that I have 10 pencils in my pocket. You're going to think that I have $10. But if you call me and you say, where are you? And I'll say, I'm driving. And you ask me, what is your speed? I'm not going to say 40 miles. I'm going to say 40 miles per hour. That's the correct measurement unit for speed, right? Rate of change of distance with respect to time. So here, what does this mean? X equals 9 what?
Years.
Yes. So now let's identify what it means. It says when y is 0, x is 9. Yes, the ordered pair is 9, 0. But what does it mean? We drive, yes, Bob?
I would say analytically to mean that after 9 years, it probably worth nothing.
Like my car.
It will all depreciate.
Like my car. After 19. How much do you think I'm gonna get for it? With 320,000 miles on it. Yes, and I bought it with 7. So value 0. Okay? We drive off, we pay $45,000, and in 9 years, 0 value. Very good. Part B. In part B, we have find the y-intercept. How do I determine the y-intercept? Exactly, position. So then y equals 45,000. So I'll say here value 0 after 9 years. Very good. So what does this mean? This is in dollars. So what does this mean? Yes, 45,000. And it means at the age of 0, yes, when we first drove it off the lot, right? Initial value. I don't know if it's value, but initial cost. That's what we paid for it. It may not be worth as much. They may have inflated the price, who knows, but that's what we paid. Okay, part C. Use the intercepts to graph the equation. So here it is. I have to select the proper unit because I'm not going to have 45,000, right? I'm going to say 10, 20, 30, 40, 50, and this is my 45,000. And then 9 years, I'm going to say 2, 4, 6, 8, 10, and this is 9. So 9 comma 0. So here's the graph of y equals negative 5,000x plus 45,000. And now you can say, wait a minute, go back to the previous problem. You extended here. You extended the equation to infinity and to negative infinity. Why don't you do it here? For several reasons. Because first of all, x is number of years, so we cannot not go back in time. X cannot be negative. And why don't I extend it below? Because I cannot say that the value will be a negative value.
They clarify that you have to pay somebody to come
It could be a money pit at this point in time, but I still cannot consider a negative value. So that's why I don't extend it. Negative time doesn't make sense, and negative value doesn't make sense. Okay, part D, which we already did, we graphed. Okay, and no, this was part C. Part D, sorry. This was C, and this is D now. Use the graph to estimate the car's value after 5 years. So if I use the graph, I don't know how accurate I'm going to be, but we can determine that. So 2, 4, 5. Here's what I do. I draw a vertical line, or imagine that I draw the vertical line at 5. It crosses the function at a point, and then I will be reading the y value. I don't know if it's true from the graph, but I can determine it from the equation in a minute. So what does this mean? What will you read? When x is 5, what will you read for y? According to my graph, which is not an accurate graph, for sure. What will you read?
What did you put, the vertical axis, what did you put as your
10,000, 20,000, 30,000, 40,000, 50,000.
20,000?
It appears to be 20,000. I don't know, but I can determine. I have the equation, which is y equals negative 5,000 x plus 45,000. How do I determine, according to the equation, how do I determine the value after 5 years? What should I do? Oh, I'm so sorry, Maureen, please. of course. X for, exactly, that's what we did from the graph. Absolutely. So for x equals 5 years equals negative 5,000 multiplied by 5 plus 45,000. So this is negative 25. Unexpectedly, my graph was correct. Unexpected. I didn't know whether my graph would be correct or not, right? I don't have graph paper. I just graphed a line. So it cannot be perfect. It happened that for 5 it worked out very well, and it is indeed 20,000. Perfect. Moving on. The next section talks about slope. Any questions for me? Don't let me move on if you have questions. Any questions?
So,
Please.
find the 5 digits carrying 5 spaces on the x-axis.
Yes, because the unit I took was 2, 4, 6, 8, 10 to graph the 9, to plot the 9. Better? Was that the question?
Yeah.
Perfect. Okay, let's talk about slope now. I'm looking to the video every now and then. I just didn't want you to think that I'm because when it gets to be close to 50 minutes, I'll stop it and start another one because it takes a long time to upload. Okay, that's what I'm looking to the left every now and then to make sure it's recording and to make sure it didn't pass 50 minutes. Okay, so this is 9.3, slope. There are 4 types of slope. A line can look like this, another line can look like this, the second option. Here's the third option, and here's the fourth option. So when we graph a line, we can encounter any of these 4 options, nothing else. What is the slope? The slope is the steepness of the line. Slope, rise over run, steepness. Which of these 4 lines you would prefer walking on? Number 1, number 2, number 3, or number 4? Obviously, number 3, because there is no effort. On this one, I won't be able to walk. There is no question there. On this one is the easiest. And the other 2, well, some difficulty level. Which means that the slope of this line is indeed 0. The slope of this line is indeed impossible. Impossible, what we like to say, undefined. Undefined. This one is a positive slope. So the notation, of course, is m. And this one is a negative slope. So 4 different types of lines, and they all have their own type of slope or steepness. Let's suppose we have 2 ordered pairs. Please give us 2 ordered pairs. Any ordered pairs you want. Make them up and get put some 0 in there maybe, and plus and negative numbers. Whatever you want. Yes? Okay, I'll start with -2, 0, and give me another point. Any point you want. 3 and 4, excellent. Perfect. So we're given basically point x1, y1, and point x2, comma y2. What we have to do here, we're asked to find the slope of this line. Find slope. The definition is, again, slope is denoted by m, rise over run, and is y2 minus y1 over x2 minus x1. We already took the time to label those points. So can anyone tell us how do I write the next step? Very good. -0. Yes. 4 minus 0. 3 minus -2. I'm trying to avoid, not because I'm lazy, but I'm trying to avoid nested parentheses. So if you know that you have the opposite of a negative number, just change it into positive instead of complicating the expression. This is what I recommend. So then the top is 4 and the bottom is 5, and that's the slope. What does this mean? Every time we go up 4, we go to the side 5. Or vice versa. Every time we go to the side 5, we actually go up 4. Okay? Let's take a look. Here it is. What is the slope of this line? 0. Very good. It's horizontal. Very good. What is the slope of this line? Undefined. Undefined. By undefined, we say it does not exist, in other words. Okay? Percentage of American reporting a lot of stress by age. Okay. So here's an example. So we have people who are age 20 or 22. They report a 49% on a particular scale. I don't know which scale. I didn't even read the problem. Percentage of American reporting. So the percentage is 49. They are reporting that at age 22, they are stressed out. 49 of them, 49% of them. At the age of 62, of course, it makes sense. They don't have much to do. They're probably retired. They're just walking around in parks. I'm not sure. So they only about 29% of them report as being stressed. What type of slope do you think this is going to have, this line? We're going to find the slope. Negative, right? Because it has a downtrend. A downtrend means a negative slope. An uptrend means a positive slope. Agreed? Perfect. So find the slope of the line passing through the 2 points and use the answer to complete the statement. Very important. We're going to complete the statement in a minute. So let's find the slope. I'm going to copy the 2 points. And this is problem 45 on page 734. So we have 22, 49. This is years, very important, and this is percent. And the other one is 62 years of age and 29%. Percent. So they want us to determine the slope. So again, I label my points, or imagine that I label them. It doesn't, you don't have to write it per se, but just make sure you write the correct sequence. And then I have 29 minus 49 over 62 minus 22. So the order is extremely important. If you reverse x with y, you're not going to get the slope. So it's rise over run. 29 minus 29 minus 49 is negative 20. And 62 minus 22 is 40. Simplify by a 10, and negative 1 over 2. Measurement unit. It's a ratio. Everything that is a ratio has 2 measurement units. One coming from the top, whatever that is, and one measurement unit coming from the denominator, whatever that is. So what is the top measured in? What is the top measured in? Percent. What is the denominator measured in? Or a year. I wrote both. So it's indeed percent per year. Remember, the measurement unit of a slope is always consists of 2 measurement units. One coming from the variable from the top, and the other one coming from the variable from the denominator. So it's the interpretation is this, and we're going to fill out the sentence. Ready? For each year of aging, let's say from 30 to 31, or from 40 to 41, or from 45 to 46, the percentage of Americans reporting a lot of stress decreased by, what should I put in here? .5. It's half of a percent. 1 divided by 2 is half of a percent, correct? So decreases by half of a percent. So at 29, it was 49%. But at 30, it's 49% minus half of a percent, which is 48.5. Yes, please.
For the rate of change, it'd be like 1% for 2 years.
Right, but we always get very good, but we calculate it per year. Yes. So you have to say by per year. It says the percentage reporting losses decreases by this, and it should be for each year. Yes, it's right here already. For each year. So it's per year. So it's by 0.5. The rate of change is 0.5 per, yeah, they want us to write it twice. So I'm going to just write it for you. So one more time, the rate changes by 0.5% per year. Very good. Any questions on the slope? Any questions on the slope? Okay. Ready to continue with the slope-intercept form and later on the point slope form. So 9.4, point slope form. Of what? Of the equation of a line. There are two equations that we are going to work with, and here is the easiest one. They're easy, both of them, but y equals mx plus lowercase b, where m is, we know what it is. What is it?
So
Very good. And this is basically 0, comma, a number. We've graphed a couple of equations. What was 0, comma, a number?
why?
Exactly. What was 0, comma, a number? Exactly, the y-intercept. 0, comma, -6. 0, comma, -6 is a point on the y-axis, this one. Then we encountered 0, comma, 45,000, which was this point. So then this number is basically part of the y-intercept, 0, comma, b. Okay, so now I would like us to look at a few examples. And I would like to maybe even go back to the previous example we had. Well, maybe not, it doesn't matter. So just give us another 2 ordered pairs. Any 2 ordered pairs, but one of them starts with 0. Okay, 0, 5, and -3, 7. Excellent. This time we're asked to find the equation of the line passing through these two. These points. What do I have to find first? And then we'll talk about parallel and perpendicular lines. Excellent. Thank you, Maureen. I have to find the slope first. We should always write y2 minus y1 over x2 minus x1 The more we write it, the less we forget. Assuming we labeled x1, y1, x2, y2, then 5 minus 7 divided by 0 minus minus 3. 0 minus negative 3, I meant to say. The numerator is negative 2. The denominator is 3. When one of the two, top or bottom, is negative, we write negative in front to divide it by 3. I have everything I need to use y equals mx plus b. Why? Because we do or we do not have the y-intercept. If you say we do have the y-intercept, then we can use this. If you say we don't have the y-intercept, then we cannot use this. Do we have the y-intercept?
Yes.
Yes. 0, comma, a number is the y-intercept. Very good. So then, can anyone dictate the equation? Y equals? Very good. Negative 2/3 x. Remember, some students say the slope is negative 2/3 x. No. The slope is only negative 2/3. It's not connected to x. It's the number in front of x. And then plus the slope, plus the y-intercept, which is 5. This is the equation. And now I'm asking you, I know I look silly when I do this, but I do it in all my classes, and I cannot not do it here with you. What is the slope, positive or negative? Will the function, the equation, we don't know functions yet. Will the equation look like this if we graph it, or look like this if we graph it? Exactly. Because the slope is? Exactly. Please remember that. Very important.
So question.
Yes, please.
So how would you do this differently if you didn't start with a nice 0.5 as a y-intercept?
Yeah, you can, but you're going to do it like this instead of doing this. You can. I accept it. Yes, Marie.
So you chose 5
Because the point is 0, 5. Otherwise, I can't choose 5. I have to find another way.
the other way would be to pick a function.
You can, yes, you can determine that point.
And plug it in.
Yeah. We don't need to do that. There's another easier way. Good, very good. But of course, I accept it. Okay, next step. Parallel and perpendicular lines. Parallel lines will look like this. Perpendicular lines will look like this. With 4 90-degree angles. So the first two are parallel, the second set of pairs, that set is perpendicular. Okay, so then here, this is the slope of line 1, and this is the slope of line 2, and they have to be the same. If two lines have the same slope, they are parallel, and vice versa. If they are parallel, they have to have the same slope. They have to have the same steepness. Well, what happens here? So here we have a totally different situation. There is still a relationship between the slopes. So let's say this is slope m1, this line has a slope m1, and this line has slope m2. What? Yes, you remember?
They're dependent, like they're
Negative, multiplicative, inverse. Yes, they have to be in a relationship. And the relationship is m1 equals the opposite of 1 over m2. I don't like this relationship. I cross multiply, and the easier one is this. They are the same. It doesn't matter which one you remember. But this one, it would take me 3 seconds, 4 seconds to even explain it, right? Or 10 seconds. One slope is the negative multiplicative inverse of the other. Here I say the product is -1. Same thing. It's up to you what you want to remember. They are identical. Okay, so let's take a look at one example here. Choose any problem you like. It says, identify whether the lines are parallel, perpendicular, or none of the above. What I would like to choose is either 53 or 54 or 55 or 56. But it's up to you. Since I asked, I let you choose.
About 55.
55, okay, let's take a look at 55. That's my page 7. So 55, and that's on page 744. And it
The
has,
focus not changed.
very good, thank you. So 2x minus y equals -1, and x plus 2y equals -6. So the question here is really asking us, are these two lines parallel, perpendicular, or none of the above? And my answer is I have no clue. But if I present them both like mx plus b, both of them, let's say this one is m1 and mb1, and this is m2x plus b2, when I solve them for y, then I'll compare. If they are the same, I'll say parallel. If they're not the same, I'll multiply them, and then maybe they are perpendicular. If they are not the same and the product of these two is not -1, then I'll say none of the above. But I have to bring them into this form. I have to change them into y equals mx plus b in order to compare. Okay, so let's solve the first equation for, of course, for,
One.
exactly, and let's solve the second equation, of course, for, only if I have them solved for y I can compare, right? So the first equation, I bring 2x to the other side, so -y equals -2x minus 1. Present everything in descending order. This is very important, so we can identify correctly. So what is the next step here? It's not done.
Multiply both sides by -1.
Indeed. Thank you, Bob. Y equals 2x plus 1. This is done. Can anyone identify immediately the slope of the first line for us, comparing this to this? I need to compare this to identify the slope. What is the slope? Careful. Remember we said, some students say, when I ask them what is the slope, they say -2/3 x, and I said the x has nothing to do with the slope. Clear? Perfect. So what is the slope then? 2. Awesome. We continue with the second equation. Let's take a look at the second equation. The second equation is 2y equals -x minus 6. We're solving for y. It's not done yet. What am I doing? I have to, to solve for y, I have to do what?
Get rid of the 2.
Which means I have to do what to both sides? By 2, of course. Divide by 2, both sides. 2y divided by 2 is y. -1 divided by 2 is -1/2 x. -6 divided by 2 is -3. Can anyone identify the slope of the second line for us? Excellent. So we have two slopes. My first question is, are they the same? No, they're not the same. Very good. So the lines are definitely not what? Excellent. So now I'm going to multiply them. If 2 multiplied by -1/2 If it equals -1, then the lines are perpendicular. If it does not equal -1, then the lines are not perpendicular, they are not parallel, so they are not in a particular relationship that we are interested in. Is this product -1?
Yes.
Yes. Therefore, lines are perpendicular. This is the symbol for perpendicular. Questions? Yes, please, Maureen.
You just put in 1/2 till y equals 2x plus 1. How did you get the
So I had one slope that was 2. I had the other one that was -1/2. When I multiplied these two numbers, 2 and -1/2, I got exactly -1, not -2 or +3 or 0 or anything like that. I got exactly -1. So I have to conclude that the two lines are perpendicular. Very good question. Is that clear, everyone? Yes? Okay. Last section for today, 9.5, which is the other equation that we are going to look at. So 9.5, point slope form of the equation of the line.
I thought we could call 9 to a point slope form, but it didn't look like it.
The first one was point slope form. This one is, the first one is slope intercept form. This is point slope form.
Point slope. I could be wrong. I think the label is point slope. 9.4.
Slope, the previous one,
Go back to 9.4.
this one,
Go back to your header.
if I did, I have to correct it. I did.
That's really slope intercept.
I'm sorry. Thank you. I cannot get away with anything in this class. Just kidding. Thank you, Bob. I didn't mean that, of course. I got ahead of myself. Indeed. Good point. Slope intercept form, of course, that's what it was. My apologies. Slope intercept form of the equation of the line. Thank you, thank you, thank you, thank you. Sorry, sorry, sorry. After the slope, I have to talk about this, and then I have to talk about point slope form. Yes, thank you. My apologies, guys. I hope you find it in your heart to forgive me. So y minus y1 equals the slope times x minus x1. This is the point slope form, in which we have the slope and a point. It can be the y-intercept. It can. But this is not typical. So x1 comma y1 is a point. Not necessarily the y-intercept, but it can be. And I have a tent that I put up because of the sun. It's my tent. Okay, very good. So let's look at any problem? On page 754, we're asked to, we're given two ordered pairs, and we're asked, and as you see, none of the ordered pairs is the y-intercept, and we're asked to find the equation of the line. Is 22 okay? -6, 1, and 2, -5? Okay, so 22 on page 754. And one more time, it was -6, 1, that's 1 point. The second point is 2 comma -5. As we see here, we do not have the y-intercept. So this is not the easy type. But that's still easy. We have to find a slope. We write y2 minus y1 over x2 minus x1. We carefully plug them in as negative 5 minus 1 over 2 plus 6. Negative 5 minus 1 over 2 minus negative 6. The numerator is negative 6. The denominator is 8. We put the minus in front, and we have to simplify 6 over 8 by 2, and we get negative 3/4. Now we have everything we need to complete and find the equation, right? So y1, you choose, but you cannot choose y1 from here and x1 from here. It doesn't matter which point you use. So let me copy the equation one more time. So y minus y1 equals the slope times x minus x1. The slope is definitely negative 3/4. We just determined it. And it doesn't matter which point you would like to use. Which one? The negative 6, 1, or 2, negative 5? Very good. So 2 will be written under x1, and negative 5 will be written under y1. And now finally we can write the equation, and we have to solve for y. So y plus 5. I'm trying to skip those or omit those parentheses inside parentheses. We call them nested parentheses. So that's why I'm doing that. Equals negative 3/4, and this is clear, x minus 2. We have to distribute negative 3/4 to both terms, and then eventually we will move 5 to the other side. So when I distribute negative 3/4, negative times negative will become positive. Let's multiply on the side. 3 over 4 multiplied by 2 over 1. It's always wise to simplify first before you multiply. So then you get 3/2, and then you will bring a negative 5, and that's your y. It's not done because I have to find the least common denominator and perform this operation here. What is the least common denominator? Let's do that on the side as well. So 3/2 minus 5 over 1. What is the least common denominator? And there is only one. 2. So then this one needs an adjustment of 2. Because the denominator was 1 multiplied by 2, the numerator has to be multiplied by 2 as well. So then we have 3 minus 10 at the top, which is negative 7. Negative 7 divided by 2, or negative 7/2. And this is the answer for this. So finally we have y equals negative 3/4 x and minus 7/2. Oops, what happened here? Minus 7/2.
Do you care whether we write that as a decimal or fraction or mixed number?
We prefer fractions. And the reason is sometimes you're not going to be able to, it could be an irrational number, so we want to keep it.